working through these examples, we are given a function, a polynomial function, and we want to graph it. So we are just doing sketches. We are not doing precision graphing at this point. But for the most part, pretty much for all the part, we're going to find the lead coefficient first and figure out what that does with our end behavior and the number of solutions. And then we're going to find the y-intercept, and then we'll go in and find the x-intercepts, because that's the hardest thing to do. So looking at this example, since this is already organized in descending order, I know that my lead coefficient is a negative x squared. So I have an x to the even, which means that my arms are going in the same direction, either both up or both down. And since this is negative, I know that both arms are going down. So from there, that's the end behavior. Now I need to go in and identify how many solutions I'm going to find, and I still do that with the lead coefficient. I'm going to find 2 solutions. So I know both arms are going down, and I also know I'm going to find 2 solutions. So now I can find the y-intercept, which means I'm going to take my x values and put it in a 0 for x's and see what pops out at the end. So I have a negative 0 squared minus a 3 times 0 plus 4. So I get 0 minus 0 plus 4 is 4. So I know what my y-intercept is. Now we're going to find our x-intercepts. So I have x-intercepts means I set my equation equal to 0 and I go from there. So I've got a negative x squared minus a 3x plus 4 is 0. Since it's equal to 0, I can do math on both sides. And I don't like the fact that I'm leading off with a negative. So I'm going to divide both sides. Divide both sides by negative 1. So that gives me a positive x squared, a positive 3x, and a negative 4. So I need 2 numbers that multiply to negative 4, because since it's quadratic, that tells me to either factor, or use the quadratic formula, or complete the square, or use square root methods. So factoring is usually my fastest way out. So I need 2 numbers that multiply to negative 4, so your signs are different. They add up to 3, which gives me x plus 4, x minus 1. So my 2 solutions, if my factor is x plus 4, my solutions are negative 4. And if my factor is x minus 1, my solution is positive 1. So with that information, I can now graph this thing. So I know that my x-intercepts are at negative 4. So here's 1, 2, 3, 4. And at positive 1. So there's negative 4 and positive 1. I also know that I have a y-intercept at 4. So 1, 2, 3, 4. I know that my leftmost intercept, from there it will go down. So I'm just going to drop that down. And my rightmost intercept, from there, it will go down, because that's the end behavior. So again, this is a sketch. This is not perfection. And then I know that this is a parabola, and it needs to be symmetric. So there we go. So that is your very, very rough sketch. I didn't bother finding out what the vertex is. I could, but I just want to find out what the basic shape of this thing is. Okay, so if you are asked to find the vertex, you knew that based on the previous module. So we are going to do the next one. So again, same order. We are going to find, I have g of x equals 3x squared minus 5x minus 12. My lead coefficient, once it's been organized, is a 3x squared. So I know it leads off positive, and I know it's an even degree. So both of the little arms are going to be going upwards. I know I'm going to find 2 solutions. And it's positive, so it goes up. Okay, so now I'm going to find the y-intercept, which means I am going to put in zeros for my x's, which gives me, if I put in a 0, I get a negative 12. Okay, so 0 minus 12. I evaluated at 0, I got a negative 12. And now I can find my x-intercepts. So for my x-intercepts, I take my original function, and I set it equal to 0, and I solve. So I need to use the AC method here because I've got a lead coefficient that's not 1. So I'm going to multiply first and last. I get a negative 36. 3 times negative 12 is negative 36. So two numbers that multiply to negative 36 and add up to a negative 5 are 4 and negative 9. So I'm going to replace my negative 5x with a 4x and a negative 9x. So I was lazy over here and didn't include the x's, but I need to include them here. I'm going to factor out the first two. I can pull out an x, which leaves me with 3x plus 4. On the next two, I can factor out a negative 3, which leaves me with a 3x plus 4. So my two factors are going to be a 3x plus 4 and an x minus 3. So again, I'm looking for two solutions. If my factor is x minus 3, my solution is positive 3, 0. And then this one, if you set that equal to 0, you're going to get a negative 4, and then you're going to divide by 3. So I end up with a negative 4/3 when I set this one equal to 0. So what does that look like? We have a bigger piece of paper because we have a y-intercept of negative 12. So I do know his arms are going to go up. I know I've got an intercept at 3. So 1, 2, 3. I've got an intercept at negative 4/3, which is negative 1 1/3. So there he is. My y-intercept is at negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the leftmost intercept, it will go up from there. So here's my leftmost intercept. My rightmost intercept, it will go up from there. And then from here, using symmetry, I know that the vertex would be between those 2 points. So this is going to drop down, and then it's going to come back up, which is a really, really horrible graphic representation. But there you go. So that is my basic sketch of what that graph looks like. So what I'm looking for when I grade your mastery topics is, do you have the end behavior correct? Do you have your intercepts correct? That's what I'll be looking for. Okay, so let's do another one. We have, this one gets a little bit more exciting. So I've got f of x is x to the third minus 3x squared plus 4. So first of all, do not fall into the pit of despair. Do not think that this is a quadratic. You're missing an x term. So this is going to have 3 solutions. How did I manage to lose my highlighter? All right, so in descending order, my lead term is an x to the third, and it leads off positive. So the end behavior says I'm going to go up and to the right, and I'm going to go down to the left, and then I'll have some little hiccups in there. It did not get flipped, okay? So that's why it's going up to the right, down to the left. And I'm going to find 3 solutions. So I know what my end behavior looks like, so now I'm going to find the y-intercept. So for the y-intercept, I put in zeros for my x's. So I find out that my y-intercept is at 0, 4. For my x-intercepts, this is going to get a little bit more intense because I need to find out what all 3 of them are, and this is not factorable. So when I look at this, I've got an x to the third minus a 3x squared plus a 0x, you need a placeholder, plus 4 equals 0. So again, if this was factorable, I could factor it and be done, but it's not, so I'm going to have to use the tools that I learned last week to find those solutions. So I'm going to narrow down the pile by saying, by doing rational zeros theorem. So factors of your last over factors of your first. So factors of 4 over factors of 1. And that's going to give me my pile to pull from. So 1 over 1, 2 over 1, 4 over 1. So my pile includes positive or negative 1, 2, and 4. Which means there are 6 possibilities. Okay? I'm going to narrow it down further by doing Descartes' rule of signs. And I personally am just going to do it as it stands. I'm going to find the positive values first. So my first term is positive, my second term is negative, my third term is 0. So I don't count that for Descartes' rule of signs because 0 cannot be positive or negative. And then I've got a positive 4. So as I read that from left to right, I was positive, I changed to a negative, and then I changed to a positive. So I have 2 sign changes. So I'm either going to have 2 positive solutions or I'm going to have no positive solutions. Well, if I'm looking for 3 solutions and the most I can have for positives is 2, that means there's 1 solution unaccounted for, so that must be a negative. So here's what that means. You're going to have 1 negative. So either I'm going to have 2 positive and 1 negative, or I'm going to have no positive and 1 negative and 2 imaginary. That's what that means. So bottom line is I'm guaranteed a negative answer. So I'm just going to start looking for negatives. I don't know if I'm going to have a positive answer or not because they could both be imaginary. So I'm going to start looking with negatives. So I'm going to try a -1. And if I don't get a 0 at the end, I'm going to try a -2. So I'm going to fill this in. Do not forget about your placeholder. I've got a 1, a -3, a 0, and a 4. So -1 times 1 is -1, which gives me -4. -1 times -4 is 4. And then -1 times 4 is -4, which gives me a 0. So we have one of our solutions. One of my x-intercepts is at -1. This is now quadratic. This was an x to the third. Now this is an x squared. So I have 1x squared minus 4x's plus 4 is 0. So what do I do with that information? Well, I can factor it. I need 2 numbers that multiply to 4 that add up to -4. So that's going to be x minus 2 times x minus 2, which is the same thing as x minus 2 squared. Okay, so if this factor, if x minus 2 is my factor, then 2 is my solution. If x minus 2 is my factor, then 2 is my solution. So now we're back to multiplicity. So this part is x minus 2 squared, which means at 2, he's going to behave like a parabola does. He's going to bounce off that axis. So what do I have? I have a y-intercept at 0, 4. So I've got 1, 2, 3, 4. Okay. I have x-intercept at -1. And then I have an x-intercept at 2. So on the graph, the way that I'm going to represent this twice is by the shape of the graph. So I can't just say, you know, here's a 2, here's a 2. I've got to show it somehow with the graph. So I know that the leftmost x-intercept is going to drop down. I know the rightmost x-intercept is going to go up. And the way that I am going to connect these dots is by coming up and then I'll come down. And that right there needs to behave like a parabola does because it's an x squared. I've got an x equals 2 twice. So that's going to behave like a parabola. So that is my extremely rough sketch of what this cubic looks like. So our final one, we have f of x equals, I've got a -2x to the third minus a 9x squared minus a 7x plus 6. So I notice that he's already organized, so my lead coefficient is a -x to the odd. So he's been flipped. So he's going to go up to the left and down to the right. Up to the left and down to the right. I'm looking for 3 answers. So I've got my end behavior down. Let's find our y-intercept by zeroing out our x's. So I get a -2 times 0 cubed minus 9 times 0 squared minus 7 times 0 plus 6. So I used a 0 for my x's and I got 6 for an answer. My x-intercepts, again, I'm going to have to do a little bit of work. So I'm going to set this equal to 0. If it were factorable, which it's not, I would go ahead and factor it and be done, but I'm going to have to use the tools that I learned last week. So rational zeros theorem. I'm going to use factors of 6 over factors of 2. I don't care that it's a negative 2 because I'm going to handle the positive negative in a second. So for factors of 6, I've got 1, 2, 3, and 6. For factors of 2, I've got 1 and 2. So I'm going to take everything in the top over 1. So I get 1 over 1, 2 over 1, 3 over 1, 6 over 1. Then I got 1 over 2, which is a half. I've got 2 over 2, which is 1. I've got 3 over 2. And I've got 6 over 2, which is 3. So I did not need that comma. So out of an infinite number of places where it could cross the x-axis, I've narrowed it down to 12 because these can all be positive or these can be negative. So there's a total of 12 options there. And simply because I know where we're going, I am going to use 1/2. Okay, and I'm going to see if 1/2 works. Actually, I'm going to do Descartes' rule of signs first. Sorry. Descartes' rule of signs. So I have a negative, 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 positive. Negative, 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 positive. So how many sign changes do you have? Stay the same, change. So I'm going to have one positive answer. One positive answer. So I could start with 1 and see what happens. Start with 2, start with 3, start with 6, but these videos are already long enough. So I'm going to tell you to try 1/2. If a fraction is going to work, it's going to be very, very pretty. If a fraction is not going to work, it's going to go really ugly really fast. So let's see if this works. What is half of -2? That gives me -1. So see how it's pretty so far? Okay, so -9 and -1 is -10. So what is half of -10? It's -5. So see how it's still pretty, okay? If you start getting fractions, just stop. So -7 and -5 gives me -12. What is half of -12? It's -6, which gives me a 0. So I know that 1/2 is one of my solutions. 1/2, 0 is one of my solutions. So now what I have is a -2x squared minus 10x minus 12 is 0. I'm going to go ahead and divide everything by -2 because I don't want to lead off negative, and I can do that because it's equal to a number. So that's going to give me an x squared plus 5x plus 6, which factors down to x plus 2, x plus 3. So if my factor is x plus 2, my solution is -2. If my factor is x plus 3, my solution is -3. So when I go to graph this, I've got a y-intercept at 0, 6. So 1, 2, 3, 4, 5, 6. I have solutions at 1/2, -2, and -3. So here's -3, -2, and there's 1/2 squished in there. All right, so my leftmost, I'm going to go up and away from. My rightmost, I'm going to go down. And I should mention that there's no multiplicity. We were looking for 3 answers, and I got 3 different answers. Where are they? I got 3 different answers, so they all have multiplicity of 1. So I don't have to worry about anything looking like a little parabola or anything like that. So now I just need to connect these dots. So I'm going to come up here and go down there. There you go. So that is an extremely rough sketch of what that would look like. And that's all I'm looking for.